What would you think if I told you there was a magic box that sped up a process that took multiple weeks into just 2 hours? You must think I'm joking, right? Well, while the Flash doesn't exist in real life, I'm not completely lying either. This magic box is called the GeneXpert machine, and it has revolutionized the world of tuberculosis testing.
You may be shocked to hear that tuberculosis is one of the world's leading infectious killers. TB is caused by Mycobacterium tuberculosis, or MTB for short, and she is not like other girls. MTB grows much slower than most bacteria, which means that traditional tests that track bacterial growth can take from 2 to 8 weeks. And the longer a test takes, the later the patient can initiate treatment, and the more time the disease can spread uncontrollably.
And this is why the GeneXpert is so magic. This machine does not rely on MTB's slow bacterial growth, and instead harnesses the power of a biotechnological technique called qPCR, which only takes 2 hours.
Inside the GeneXpert, the real stars of the show in qPCR are molecular beacons, segments of DNA designed by scientists to recognize specific sequences of nucleotides and announce their presence through fluorescence. The molecular beacon has 4 main components: the probing sequence of nucleotides, complementary base pairs on either end to close the beacon like a hairpin, a fluorophore, and a quencher. With no match for the molecular beacon's sequence of nucleotides, the structure stays in this closed position, and when the GeneXpert shines light on the fluorophore, the light that the fluorophore re-emits is absorbed by the quencher and is not detected by the machine. However, if the complementary sequence to a molecular beacon is present, then the beacon will open up as the sequence binds to the MTB DNA. Now that the fluorophore and quencher are separate, light re-emitted from the fluorophore is detected by the GeneXpert, indicating that the specific sequence of DNA is present in the sample. Using molecular beacons with different sequences in colored fluorophores, the GeneXpert can also assess if the MTB has certain mutations, which make it resistant to common drugs, allowing doctors to set patients on the correct course of treatment from the start.
So the GeneXpert is faster and more informative than traditional testing methods. But in countries using the GeneXpert like Uganda, it's still taking weeks for people to get results that should take 2 hours, because the world outside of our magic box is far from magic. These factors are delaying treatment and costing millions of lives. As scientists, we cannot isolate ourselves from these societal issues. We must collaborate across the globe and counteract these unnecessary injustices to let the magic in our box do its work.